Welcome children to this session. Today we are going to discuss another important lesson in your physics, that is gravitation. This lesson has got number of interesting concepts children, which you find them very interesting and easy. Wherever necessary you can make a pause and write down the notes children. Today we are going to see number of concepts from this lesson. Let's begin with this gravitation. The introductory part I have taken from your 8th standard lesson children. Geocentric theory and heliocentric theory. These are the two known theory to you children. Geocentric theory, which was proposed by Ptolemy in 2nd AD. This theory says, according to this theory, Earth is the center. All the planets, including the Sun, move around the Earth, which was proposed in the 2nd century, which was followed till 16th century. See how many centuries people have believed what was said. Around 17th century, this heliocentric theory comes into existence, children. This was proposed by Nicholas Copernicus. He was a priest, a monk. He proposes this theory. According to this theory, Sun being the center, all the planets move around the Sun, what we have at present. This theory came into existence after 17th century. Till now, we believe this heliocentric theory is the true one. Followed by a Denmark scientist, astronomer comes named Tycho Brahe. He was the first scientist who said to have collected maximum quantity of statistical data regarding celestial objects. What is the period of rotation? What is the period of revolution? What is the distance between the two given planets? What is the distance from the Earth to the Sun? All these statistical data was devised by Tycho Brahe. Johannes Kepler takes the help from this Tycho Brahe. He proposes 3 laws and he mentions them as laws of planetary motion. This is a series of linked children. Then Sir Isaac Newton, he takes the help of Johannes Kepler. He concises the 3 laws of planetary motion and gives one law called universal law of gravitation. That's how this gravitation lesson has come into existence. So this is our introductory lesson children. An object which is thrown into the space falls down towards the earth always. It's a common activity which we see, which we have seen, experienced. Whichever the object which is thrown into the space, it falls down towards the earth only. What was believed? It was believed that Earth attracts all the objects towards its center. This was the only thought which we were having it. But it is not the truth. But the truth is, every object in the universe attracts one another with a force. This is the reality, children. This we call it as gravitation. There is a big difference between gravity and gravitation. Gravitation is nothing but the force of attraction between any 2 objects in the universe. The earth exerts force on the moon exerts force on the earth. Gravitation. Therefore, gravitation is an attractive force. It is an attractive force. The force of attraction between objects is called gravitational force. Simplest definition. The force of attraction between any two objects is called gravitational force. There is a force called centripetal force. This is the new concept to you children. Listen carefully. Centripetal force. Whichever the object which moves in the circular path will have a force called centripetal force. Even a person who runs in the circular path, planets move in the circular path, all will have a force called centripetal force. We have seen in the lesson called motion, when an object moves along the circular path, one thing changes continuously. What was that? When a body moves in a circular path, its direction changes continuously. Therefore, the body is said to be accelerated. It was discussed. Body is said to be accelerated. When there is change in velocity, acceleration takes place. So, when a body moves along the circular path, it will have a force called centripetal force. In one sentence, this centripetal force is nothing but central seeking force. Force which is directed towards the center, acting on a body along the circular path is known as centripetal force. The force that is directed towards the center, which causes the acceleration, we have seen. When a body moves along the circular path, its direction changes. Therefore, it is said to be accelerated. It causes acceleration and keeps the body to move along the circular path. This is the force. Centripetal force is the reason behind the motion of the body along the circular path. So, the force that is directed towards the center, which causes acceleration and keeps the body to move along the circular path, is called centripetal force. In short, the force which is directed towards the center, acting on the body along the circular path is known as centripetal force. The diagrammatic representation I have taken, children, a stone which is tied to a string and it is whirled around. See, the stone always attracted towards the center. Therefore, this force keeps the stone to move in the circular path. The earth and the moon. There is a force of attraction. This force is central seeking force, which is attracted towards the center. The force which is directed towards the center, acting on the body along the circular path. Example. Motion of the moon around the earth is due to centripetal force. Whichever the objects which are in circular motion will have this force. Next important concept is this, the linking. This centripetal force is provided by the gravitational force of the earth, force of attraction between the earth and the moon. Now, we look into the definition part of gravitation. The force of attraction between any two objects in the universe because of their masses is called gravitation. As we have discussed, children, there is a difference between gravity and gravitation. Gravitation is an attractive force of attraction between any two objects in the universe because of their masses. The force of attraction between the earth and the moon, the force of attraction between the sun and the planets can be taken as example of gravitation, a gravitational force, a force of gravitation. Any two objects in the universe attract one another because of their masses. The force of attraction between the earth and the planet. the force of attraction between Sun and the planets. What is the gravity? Gravity. It is nothing but the attractive force of the earth on other objects is called gravity. The attraction between the earth and the objects near to its surface. Example, a coconut falls towards the earth. Apple fell towards the earth. The objects thrown up into the space fall back onto the surface of the earth. Falling apple is attracted towards the earth because of the gravitational force of the earth. Your question now, falling of apple. Apple fell down, it gets attracted towards the earth, therefore it fell down towards the earth. There is a force of attraction as per gravitation. There is a force of attraction between the earth and the apple. Only the apple moves towards the earth, not the earth moves towards the apple. Why? Because if we compare the mass of apple and the mass of the earth, the mass of the apple is negligibly small. Therefore, it falls towards the earth. Otherwise, if the apple would have been bigger than the earth would have moved towards apple. So, this is the reason. Earth does not move towards the apple. Earth does not move towards apple because mass of the apple is negligibly small. Now, you might have been in a better position of understanding regarding gravitation and gravity, children. Gravitation, the force of attraction between any two objects in the universe because of their masses. Every object in the universe attracts the other object with a force. But gravity is the force of attraction of the earth on the surface of the objects. Based on this, a law was proposed. This law is known as law of gravitation. This law states that every object in the universe attract one another with a force which is directly proportional to product of their masses and inversely proportional to the distance, the square of the distance between them. The force, existence of force directly proportional to product of their masses. If the masses are more, the force of attraction between them becomes more. If the distance between the objects become more, the force of attraction between them becomes less, because one is directly proportional, another one is inversely proportional. The force, every object in the universe attract one another with a force which is directly proportional to product of their masses and inversely proportional to the square of the distance between them. Consider these are the two objects of mass capital M and small m, or else you can take small m1, small m2. Then the distance from the center to the center is taken as d, children, distance between them. By looking at this formula, we will be able to say the law of gravitation. Every object in the universe will attract one another with a force which is directly proportional to product of their masses and inversely proportional means in the denominator, inversely proportional to square of the distance between them. This is the formula part, children. You need to learn the law as well as formula part. M and small m, these are the masses of two objects. D, distance between them. F, the force of attraction. What is this G? G is known as universal gravitational constant, which has got a typical value, children. The force of attraction between any two objects in the universe is directly proportional to product of their masses, and inversely means 1 by inversely proportional to square of the distance between them. Then this is how the formula comes. G capital M small m by d square. G is known as universal gravitational constant. Note on G. What is that we must know regarding this capital G? Capital G is known as universal gravitational constant, which has got a particular value which is about 6.67 into 10 to the power of minus 11 Newton meter square per kg square. It's saying it also, you need to remember, children. Its value is this. This value is constant. The value of G was determined by Sir Henry Cavendish, scientist. The value of G is same throughout the universe. These are the few points that you need to remember regarding this value G. This law is called universal law, children. Universal law of gravitation, we say. Why do we call this law of gravitation is known as universal law of gravitation? Why? Because this law is applicable to small and large masses. Whichever the masses you consider and calculate, this law holds good. This law also applicable to small and large distances. This law also applicable to celestial bodies, not only on this planet, even to the outer space. Therefore, these are the three reasons suggests that this law is called universal law of gravitation. Importance of this law. This law, children, successfully explained few concepts. These are the importance of universal law of gravitation. The first one, the force that binds us to the earth. The second one, the motion of the moon around the earth, the motion of planets around the sun, the tides due to the moon and the sun. These were the four concepts well explained by this law. Therefore, these are the importance of universal law of gravitation. Successfully explained the force which binds us to the earth, motion of the moon around the earth, motion of the planets around the sun, tides. Tides are nothing but the waves, strong waves due to moon and the sun. Is there any change in the velocity of falling objects from a height? Is there any change in the velocity of falling objects? Imagine you have climbed about a building which has got around 10 stories. You drop a stone from it. Do you think there will be change in its velocity as it moves towards the ground? Think. There is change in its velocity is the answer, children. Velocity increases by equal amounts. Therefore, free fall. This is an example for uniform acceleration. Uniform acceleration we have seen in your previous lesson. The velocity of an object increases or decreases by equal amounts in equal intervals of time. Then we say it is uniform acceleration. The same thing happens. When an object is dropped from a height, velocity increases. Okay? There is change in the velocity of the falling object due to gravitational force of the earth. There is no change in the direction of the falling object. So, uniform acceleration is produced in the object. Therefore, how do we define the word free fall? Free fall, as the name itself says, free fall. The falling of an object from a height towards the ground under the gravitational force of the earth is called free fall. The falling of a body from a height towards the earth under the gravitational force of the earth is called free fall. The diagrammatic representation, children. What is that we need to be understood in this? If two objects of same type but different sizes are dropped from a height, which will reach the ground first? You have taken two stones of same type, which is one is bigger, one is smaller one. Both the stones are dropped from the same height, which is about 500 meters above the earth. Which stone will hit the ground first? Think, children. The same experiment has been taken. Don't heavier objects fall faster? Do you think that the heavier object will fall down first? Let's find out. Aristotle arrived at a wrong conclusion that heavier body falls faster than the lighter object. Aristotle, he gives a wrong conception, saying that heavier object will hit the ground faster. But that is a wrong thing. Then, who rectified it? Who said the correct concept? Galileo removed the misconception and proved that all bodies, irrespective of their mass, fall at the same rate towards the earth. He says that, Galileo says, both the stones, irrespective of their masses, will hit the ground at the same rate, at the same time. Okay. Galileo, he proved this experiment from Leaning Tower of Pisa, which is in Italy. Galileo, scientist who conducted experiments on freely falling objects. Both the objects fall at the same rate. Robert Boyle, another scientist, he proved that in vacuum, a coin and a feather fall at the same rate. It must be a vacuum. See, look into this term, children. In vacuum, where there is nothing, even air molecules, absence of air molecules. So, if vacuum is created in a place and a feather and a coin is left, both the objects will hit the ground at the same time. That was proved by Robert Boyle. Next, we will look into, children, acceleration due to gravity. Acceleration due to gravity, small g. Acceleration we have learned from 8th standard. When there is change in the velocity of an object, acceleration is produced. When a body moves along the circular path, it changes its direction, therefore velocity changes, therefore acceleration exists. Body is said to be accelerated. Here the question is acceleration due to gravity. When an object is dropped from a height, there is change in its velocity. The uniform acceleration produced in a free falling object. When an object is dropped from a height, free fall takes place. That is an example of uniform acceleration. So, the uniform acceleration produced in a free-falling object due to gravitational force of the earth is called acceleration due to gravity. Acceleration, the uniform acceleration produced in a free-falling object due to gravitational force of the earth is called as acceleration due to gravity. This acceleration due to gravity, children, is represented by small g. You should not be confused with capital G and small g. Capital G is universal gravitational constant. Its value we have seen 6.67 to the power of minus 11 Newton meter square per kg square, which was given by Henry Cavendish. But this acceleration due to gravity, small g, its value is about 9.8 meter per second square. So you must know the definition part of acceleration due to gravity and its representation, its value, children. Free falling. Falling of an object from a height towards the ground due to gravitational force of the earth is known as free fall. Free fall, this is an example of uniform acceleration. Velocity of an object changes. The uniform acceleration produced in a free fall object due to gravitational force of the earth is known as acceleration due to gravity. Acceleration due to gravity is represented by small g. SI unit of acceleration due to gravity is meter per second square. Acceleration, SI unit of acceleration is meter per second square. Same way, we follow this also, meter per second square. The value of g is found to be 9.8 meter per second square. What is that note we must know regarding this acceleration due to gravity? Note 1. The average value of g on the surface of the earth is found to be 9.8 meter per second square. This is the note number 1. Second one, the value of g at the center of the earth is 0 because distance becomes 0. Therefore, the value of g is 0 at the center of the earth. Therefore, g is maximum at the poles, minimum at the equator. Minimum at the equator. We know that the shape of the earth is known as geoid. So, the distance from pole to the center of the earth is lesser than the distance from equator to the center. So, this is an important point, children. Question may be asked from give reason type. G is maximum at the poles and minimum at the equator. Why? This is due to geoid shape of the earth. The value of G on the moon is about 1/6 of the value of G on the earth. The value of G on the moon is equal to 1/6 of G on the earth. Factors on which value of G depends. Value of G depends on mass of the earth, radius of the earth, that is distance, then height of the object from the surface of the earth. Even an object which goes away from earth's equator, G value will goes on decreases. Astronauts find zero acceleration when they move certain distance away from earth's center. Because of its distance, as the distance increases, the acceleration due to gravity decreases. These are the three factors on which acceleration due to gravity depends on. Children, so far we have discussed about the important concepts from this lesson, gravity and gravitation. Don't be confused, children. Gravitation is nothing but the force of attraction between any two objects in the universe because of their masses. Gravity is attraction of the earth on the other objects which are on the surface. Please go through each slide slowly, children. Make a pause and write down the notes wherever it is necessary, children. Go through the text also, which will give you a variety of experience in understanding this lesson. The remaining part we will see you in our next class, children. Have a nice day, children. Thank you.